Assalamu alaikum wa rahmatullahi wa barakatuh. Our topic today is the internet and the web. By the end of this lecture, you will be able to tell the difference between the internet and the web, and you will be able to tell about the history of the internet, and you will able to describe how the internet work, and also you will be able to tell about the history of the web and able to explain how the web work, and you will be able to tell what's the internet of thing is.
As we all know, one of the marvels of modern technology is the internet. The internet actually is something you will probably use it all day long. So, what is the internet? And what is the difference between the internet and the web? You should remember the internet is a vast international network of computers, or it is simply global network of networks. It is made up of hardware, computers, and connection. So, the first thing that you should remember is the internet is made up of hardware, not software. On the other hand, we have the web, or what we call it World Wide Web. What is World Wide Web? World Wide Web is a collection of software that spans the internet and enables the interlinking of documents and other resources. For example, documents, images, and sound clips. So, the web actually is the most commonly used service on the internet. So, you cannot access to the web without the internet. As we mentioned before, the web is only pages that contains pictures, links, video, etc. History of the internet. How the internet started. In the 1960s, Advanced Research Project Agency Network, or what we call it ARPANET, precursor to the internet, was the first wide area packet switching network with distributed control and one of the first networks to implement the TCP/IP protocol suite. Both technologies became the technical foundation of the internet. ARPANET actually connected computers at four different universities. The first university is University of California, located in Los Angeles. The second university is University of California, located in Santa Barbara. The third institute is American Nonprofit Research Institute, located in Menlo Park, California. And the fourth university is the University of Utah. ARPANET actually use dedicated cables, period, underground. Actually, data transfer rate was only 56 kilobytes per second, close to modem and dial-up service. So it was very, very slow. The ARPANET demonstrated that researchers at different locations could communicate, share data, and run software remotely. So, ARPANET built the first networks among only four different universities, and the purpose of this network actually only for academic and scientific purposes. We will continue to talk about the history of the internet. After around 15 years, ARPANET added the network to more than 1,000 locations. At that time, an agency called National Science Foundation was introduced. What is actually this foundation is? It is actually an independent agency of the United States government that supports fundamental research and education in all the non-medical fields of science and engineering. Actually, this agency funded the construction of high-speed transmission line that would form the backbone of the expanding network. So, as we know from the previous slide, we should to have like the solution of the low speed of data transferring. So, the NSF developed this thing and transferred the rate of transferring of data from 56 kilobits per second up to 1.5 megabits per second. Actually, the term internet was introduced to because of the similarities between this network and the interstate highway system in United States. As it's clear on the right side, this is actually the map of United States. It is similar to the design of it. It is similar to the internet and how it goes through. Because continued growth would need more funding and research, the United States government decided in the mid 90s to privatize the internet. What does that mean? Actually, control the network's hardware was turned over to telecommunications companies or internet service provider or ISP and research organization. For example, AT&T, Verizon, Quest, Sprint. These all companies are actually the internet service provider in all over the United States, similar to what we have here, STC, Mobile, and then etc. So the internet now under the control of these internet service provider. Research and design are administered by the Internet Society. What is actually the Internet Society?
So now we will talk more about the Internet Society. What is actually the Internet Society is? The Internet Society, ISOC, is an international non-profit organization. It actually founded in 1992. What is the main purpose of it? What actually the Internet Society is trying to do? They actually promote the open development, evolution, and use of the internet for the benefit of all people throughout the world. So, Internet Society, the main objective of it is to make sure that all the people around the world can get beneficial of the internet. It also maintains and enforces standards, ensuring that all computers on the internet are be able to communicate with each other. It also organizes committees that propose and approve new internet related technologies and software. Under the umbrella of the Internet Society, we have four different organizations. First, Internet Engineering Task Force, IETF. What is actually the purpose of this organization? Actually, the purpose of it is the leading internet standards body and protocols that define the architecture of the internet. The second organization that we have is the Internet Architecture Board, IAB. What is IAB actually? IAB and the Internet Research Task Force, IRTF, both of them actually complement the work of the Internet Engineering Task Force by respectively providing long-range technical direction for the internet development and promoting research important to the internet's evolution. The last organization that we have is called the Internet Research Task Force, IRTF. What is actually RTF is, or what is the mission of it? It actually promotes research of the importance to the evolution of the internet protocols, application, architecture, and technology. The internet has been one of our most transformative and fast growing technologies. As we can see here in this table, in 1982, there was only 235 computers on the internet. In 2010, 758 million and 81,484 computers has an internet. So a big difference. Currently, in 2020, the computers that connected to the internet can be reached up to 50 billion.
Now let's talk about how the internet works. The design of the ARPANET of the today internet was strongly influenced by two key ideas proposed by Paul Barron. The first idea adopted for the ARPANET design of the internet was distributed network, and the second idea was packet switch. Let us start with the distributed network idea. To understand the logic behind the internet structure, we must recall that the ARPANET was funded by the US Department of Defense for Communication to develop a large or national-wide communication network that would be resistant to attack during the war. So the goal is to to allow the communication goes through the network even even if a part of network was damaged or destroyed, either by the enemy action or normal mechanical failure. So clearly, with this objective, the centralized network model, which rely on small number of central computer to coordinate the transmission of data through the network, would be not sufficient. For example, if the part of the network that serve particular part of uh, of of the network was down, this region or this part of network will be disconnected. The left figures on the slide illustrate this idea. If the connection between the central computer was down or failed, or one of the computer failed, the portion of this network will be disconnected. Baron proposed different architecture for computer network which resolve this issue. The design is that the control of the connection in the network was distributed to the large number of the devices. So each computer on the network was linked to several other computers. So if the particular computer or connection failed, then the communication could be routed around this part of the network, and the network would continue to transfer the data. This idea is similar to the mesh topology that was introduced in the chapter 2, and the figures on the right side illustrate this idea. If the connection between computer B and A was down, we could still send the information between them using another route. But one other idea to the ARPANET design of the internet was a packet switching. In a packet switching network, Messaging to be sent over the network are first broken into small pieces known as a packets, and these packets are sent independently to their destination. The following figures on the slide illustrate this idea. First, the message will be broken into a set of packets, and these packets will be sent through the internet independently. Then they will be reassembled. These packets will be reassembled again when they arrive at their destination. One more point to mention here in this slide, because the message sent independently through the network and they usually taking a different route, they might arrive out of the order at the destination devices or computer. So we there is a software that will be used, or protocol that is or software that is follow certain protocol that we'll see in next slide, are responsible to reassemble this messaging. Also, how this message are broken into packets, there will be uh, a protocol uh, that define how these packets will be broken and how they are labeled. Sending the messaging in this way will offer three key advantages. First, sending the information in a smaller unit will increase the efficient use of the connection. What do we mean by that? If the large message uh, were able to monopolize the connection, many smaller messages might be forced to wait. So let's take example from real life. Assume that in the checkout line at busy grocery store, if the customer has many items, uh, the customers with the few items has to wait in the line. But to avoid that, if we have express line where the number of items is limited, these customer can check out do the checkout process more faster. In a similar way, limiting the size of the network transmission will allow many users to share the connection between them. The second advantage of packet switching is that it will allow the network to react to the failure or the overcrowded route in the network. As each packet will goes toward its destination using different route, the routers, which is a special purpose computer, can recognize the failure or the overcrowded route in the network and able to reroute the package around the trouble area to reach the destination faster. The third advantage is that the packet switching improve the reliability. What do we mean by that? Because the message are broken into packets and each packet are transmitted independently, so at least part of message will arrive at destination even there is a failure to deliver some part of the message. uh, if the receive or the destination receive only part of the message, there is a software on destination computer can acknowledge or inform the sender computer to transmission the missing part. Distributed network and packet switching that we talk about it in the previous slide are describing the internet architectures. However, they don't address the following issue: how the computer that are connected to the internet are able to communicate with the another. Uh, this issue is similar to the issue that in our life people speak different language and they have different customs. So also the computer are built using different technology, operating system, and the language. So how can we make a computers, for example, in الحسا communicate, or in Riyadh or in Jeddah communicate with the other computer that reside, for example, in Italy? So the computing community agree on a protocol, which is a set of rules that describe how the communication will take place between the computer. So the Internet protocol can be thought as a mail address system, which is consists of the street address, postcode, uh, which will be provide unique address for your house. Using this address, anyone on the world can send you a letter. So the two main central protocols that control the internet communication are a transmission control protocol called TCP and the internet protocol called IP. In the next slide, we will talk about these two protocols in details. Transmission control protocol TCP control the method by which the messages are broken down into packets and then reassembled when they reach their final destination. On the other hand, the IB or Internet Protocol or IB is concerned with the labeling the package for delivering and controlling the packet path from the sender to the destination. The combination of these two protocols written as a TCP/IP and usually or is often referred to as the language of the internet. So any computer that is able to speak the language defined by the TCP/IP will be able to communicate with any other computer on the internet. The following figure illustrates how the messages are transmitted over the internet using the internet protocol TCP/IP. When someone sends a message over the internet, the first thing happen to the message is a software on the sender computer using the rules of the TCP breaks that message into packets where the size of each packet is no bigger than 15,000 characters and label the package according to their sequence, for example packet 2 of 5, packet 3 of 5, and so on. Next is software following the rules of the IP protocol labels these packets with the routing information, which include the IP address of the source and the destination computer. Once labeled, the packets are sent independently over the internet. Special purpose computer called router receive the packets, access the routing information, and then pass or forward the package toward their final destination. So the routers, which are maintained by the companies and the organization that manage the network connection, use various information sources, including statistics on the traffic patterns, to determine the best path for each packet to follow. Example of that, if you are following a familiar patterns to your destination, if you know ahead this familiar route will be closed, or will be a traffic, you will use alternative route to reach the destination. This is the router work in the similar way to route the package to their destination. Once the package arrive at their destination, they might be out of order because of using a different route to arrive. So there is a software that following a TCP, a protocol on the destination computer, which will reassemble this package in the correct sequence to recreate the original message. The internet rely on two special purpose computer in network: routers and domain name servers. Let's first start with the routers. Routers are computers that receive package and use uh, various information sources to pass the package toward their destination using the best path. Domain name server are computers used to store a mapping between a domain name and their corresponding IP address. From end user perspective, remember the IP address of the website would be difficult. So instead, we use the domain name to access the website. For example, it is easier for us to remember the google.com instead of their IP address, which is, for example, 147.321.21.84, which is difficult. So the domain name servers store the domain name and their equivalent IP address, and it's allow us to look up this information. The following figure illustrate how we look up the IP address and request a web page from the internet. When a user enter the URL, for example, creton.edu website, in the address box of the web browser, the web browser extract the server name, which is creton.edu from URL, and pass it to the local domain name server. The domain name server will look up the website in its table. If the name is found, if the server name is not found in the local, the request will be passed to another domain name server. After looking up the domain name on the table, the domain name server will return the associated the IP address. In our case here, it is 147.134.284 to the sender computers. Then the sender computer will be able to request the page index.html, which is the home page, to be sent over the internet to the web server with the IP address 14134.284. The popularity of the internet had started in early 1990 when the World Wide Web was developed. What is the World Wide Web? Uh, or a web is a multimedia environment in which a document can be linked over the internet. And this or the World Wide Web was proposed by the Tim Berners-Lee in 1989. Lee was a researcher at European Laboratory for Practical Physics, and the researcher and the laboratory were located all across Europe and using a different type of computer and software. So they found it difficult to share the information effectively. So to address this issue, Lee proposed an idea that allowed these researchers uh, uh, to exchange the data regardless of their location. So the idea or the basic idea for the web suggested that the document could be stored on the internet linked computer such that the authorized individual in one computer could have access to files stored on the other. The design of the web proposed by Lee was built on two key ideas. And these two ideas are the hypertext and the distributed nature of the internet. Hypertext is a document or text which contain a link to other text. So the web page can contain image or links to the other page. And here is example of the hypertext that has a link to other document. The second key idea is the distribution nature of the internet. The web page can be stored on the machine all across the internet, known as a web servers, and they are serving can store the web pages and serve them to the other computer that want to access. So the logical connection between the pages are independent of physical location. So you could uh, create a web page, but they are stored on the server in different country, and also the people can request these pages from different country where different location where these pages are stored. The following figure shows the growth of the web from 1992 until 2010. It is interesting to note that there is dramatic increases in the web after advances in the browser technology in 1939 until 1996 when the Internet Explorer was launched. Also, the number of the website has grown considerably during the past 10 years. In 2005, Google.com has claimed that to have more than 8 billion web pages were indexes, What do we mean by indexes? We mean that after the page is discovered, Google try to understand what is the page is about. This process is called the indexing, and by 2009, more than 50 billion web pages are indexes. And nowadays, we know this number are continuing uh, to increase. Similar to the internet communications, the World Wide Web relies on the protocol to ensure that the web pages are accessible to any computer regardless of the machine, hardware, operating system, browser, or location. So there are two standards are used to ensure that. And these protocol are hypertext markup language called HTML and the hypertext transfer protocol HTTP, which work in combination with the TCP/IP protocol to enable the exchange of the web page over the internet. We'll talk in details about these two protocols now. What is the HTML? HTML is a language used to develop a web pages. So it design the structures and the visual of the web page. The designer using this language can create the web pages by placing a tag and special symbols within the text document, and they formatted the included text in the page, and also they can incorporate links and image or other media to create the page. And the web browsers now can read the HTML tagging and render the page accordingly. And the latest proposed standard for the HTML is HTML5, which is supported by all modern browsers. Hypertext Transfer Protocol is the communication protocol that used to establish a connection between the web server that store the web page or the HTML page and the computer browser to send back the HTML or other file for the browser to view. The URL the URL here shows or now let's see how the URL are interpreted. So URL usually has a three part. The first part or the leftmost part signify that the page is to be accessed uh, uh, will be use the HTTP protocol, and the the middle part will specify the name of the web server that store the page. Uh, the the most right part of the URL specify the name of the page, and usually it is end with the .html or HTML. Now let's see the process how the communication taking place between uh, a web browser of the users and the web server to display a particular or to request particular page. When the person requests a page, first the browser will identify the web server where the page are reside. Then the browser send HTTP request to the server over the internet and requesting the page. The web Once the web server receive the request, it will locate the page within its directed directories, then send the page text back in the message to the browser, send it back to the to the user. When the message is received, the browser will interpret the HTML page format and display the page according to the browser window. And the figure on the bottom right of the slide illustrate this process. Now, how we see or view the web page? There is two terms that we need to know. It is a web page, and we know the web page is a text document that contain additional formatting information written in the HTML language. A web browser is a program which use the HTTP protocol, the communication protocol between a client and server, to access the web page, and the web browser interpret the content of the web page and display the page. And this is example showing that the web page is text document that contain HTML format. Then the browser are able, for example the Firefox or Chrome, are able to interpret the HTML, the tags and special symbols, and display the page on the browser window. And this is what happened when we request the any page and display it in our browser. Accessing a single web page might involve several back and forth between the browser and the server. And if the web page contains embedded element, for example image or sound, the browser will not recognize this until it begins displaying the page. So the browser must then send separate message to the server requesting the embedded element, like as you said image or sound. So if we assume that if we have a page that contains 10 imaging, this will require 11 interaction between the browser and server, one for the page itself and one for each of the 10 element. To avoid the redundant and the excessive downloading and connection between the server and the browser, uh, there is a technique, or the most browser use a technique called a caching. So when the page or the image is first downloaded, uh, it is stored in temporary directory on the user computer called caching. The next time the page or item is requested, the browser first check to see if it has a copy stored locally in the cache, and if so, uh, and check if the copy is up to date by contacting the server and asking how recently the page was changing. If the if the if the image or the copy is up to date, stored locally, then the browser can display this copy instead of downloading the original. So let's see example of this process. So when the first the browser on the uh, on the user computer will ask to get some pictures, then it will goes to uh, the web the cache the cache or catching the local cache, then it will check if it is if it is has it or not. If it has it, it will send another uh, request to the server, just asking if it is time by comparing the time is stamp of the picture. If it is not has changing, it will the server will reply by brief messaging to the browser. Then the browser can display it, and this will save time. If the time of taking to request the item and download it, for example, 30 minutes, then it will save more time. The following figure shows the relationship between the internet, extranet, and intranet. The internet, we know that it is a global network that can be accessed by anyone. Uh, extra or the extra or let's start with the intranet. Intranet, it is a private network operated by the organization where the employee can create content, communicate, and collaborate. And it is isolated from the global internet, and it doesn't allow access to anyone outside the network. So it is a local network, uh, and it is operated by the organization. Extranet, it is a private network similar to the intranet, but provide a control access to the authorized user from outside the organization. Example for the authorized user who can access the extranet, it is a customer, vendors, or partners, to allow them to communicate with the organization in a closed and secure virtual space. So this figure shows the intranet can be accessed only by the employee of the company. The customers and partners or supplier can be accessed by, through the extranet, and all of these are part of the internet.
What is the Internet of Things, IoT? Actually, Internet of Things also sometimes referred to as the Internet of Everythings. The Internet of Things, or IoT, refers to the billions of physical devices around the world that are now connected to the internet, all collecting and sharing data from a remote location. The data itself is stored, analyzed, and shared via the internet. How big is IoT right now? This new wave of connectivity is going beyond laptops and smartphones. It's going towards connected cars, smart homes, connected wearables, smart cities, and connected healthcare. Basically, IoT is connected our life. A good example of IoT is wearable health monitors, like many of us now wearing the Apple Watch. And uh, on the past, one of the first examples of Internet of Things is from early 1980s was Coca-Cola actually machine. Who invented or who created actually the the phrase or the idea of Internet of Things? His name is Kevin Ashton in 1999. He wrote, as he said, if we had computers that knew everything there was to know about things using data they gathered without any help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We would now we would know when things needed replacing, repairing, or recalling, and whether they were fresh or past their best. So, at the end, IoT wants to collect all potential objects to interact each other on the internet in purpose to provide secure, comfort life for human being. After we define the Internet of Things, now we will talk here more about the advantages of IoT. Is there any advantages of it? For sure. IoT or Internet of Things network saves times and money. There is no doubt that IoT saves our time and money. IoT systems delivers information fast and accurately with minimum utilization of energy. What are some example of using the IoT nowadays? IoT used now for patient monitoring. For example, various types of wireless sensors are installed on the patient body, which communicate with the IoT network and provide all required information of the patient under treatment. So the patient can be in a room and the physicians or the nurse can be in other room. By connecting those type of wireless sensors, we can monitor the patient remotely. So by know like their blood pressure, we can know everything about him remotely. The other good example of the IoT as well is it is used in home security devices, which are monitored and controlled either locally or remotely using easy to applications available on smartphones. Example: security alarm, camera sensors, door lock, etc. It also used in assist tracking, inventory control, energy conservations, shipping, etc. Also, IoT devices communicate themselves to the owner, indicating its location and conditions. Now we will talk more about the IoT in the medical field. Before Internet of Things, patients' interactions with doctors were limited to visit and tele and text communication. There was no way doctors or hospitals could monitor patients' health continuously and make recommendations accordingly. Now, with the Internet of Things, enabled devices have made remote monitoring in the healthcare sector possible, unleashing the potential to keep patients safe and healthy, and empowering physicians to deliver superlative care. Actually, IoT has application in healthcare that benefits patients, families, physicians, hospital, even the insurance company. Let's focus here more in IoT for physicians. Devices in the form patients can have like devices in the form of wearables. They can put it in their wrists, like fitness bands and other wirelessly connected devices like blood pressure and heart rate monitoring cuffs, glucometer, etc. Give patient access to personalized attention. These devices can be turned to remind calorie count, exercise check, appointment, blood pressure variation, and much more. Also, it enhances management of drugs. Like management of drugs is one of the major expenses in the healthcare industry, but with the Internet of Things and smartphones could help to manage this is in a better way. Also, IoT in medical field improve disease management by access to real-time data, medical analytics, and smart monitoring. For sure, it reduces cost. How is that? Internet of Things can improve real-time medical analytics, drugs management, and cut down unnecessary medical visit. Lastly but not least, reduce errors. How is that possible? By automated data and smart workflow controlled by devices connected to Internet of Things for better decisions based on the deep analytics. So if we have the Internet of Things and give it like many of data, they they actually can give you a better decision to make